Yeah, hi, this is Russ Somma, myself and my two colleagues here, Sam Halaby and Mike Vileikis. We're going to take you through the concepts of multi-product facilities, considerations beyond just cleaning. What that means is pretty much how you can build a facility and build in a lot of the flexibility and modularity you're going to need. This was touched upon in pharmaceutical processing in a recent article we had published. So let's take a look at the aspects we're going to be talking about. We're going to be looking at our business drivers here, and of course, we're going to look at some of the stuff about the pipelines, market strategy, market products. We're also going to be looking at market share and capital investment. Then we're going to be turning it over to Mike. We're going to be talking about some of the process development and some of the hybridization leading up to continuous process, single-use technology, and my personal favorite, scale up or scale out. And then, of course, we're going to touch on the most important part of this is how do you build it in the facility design. And Sam's good at putting this stuff on paper and getting this thing moving ahead. So we'll start talking about the business drivers. Most firms have a 5 to 10 year business plan. And in that 5 to 10 year business plan, there's usually a very broad mix of products. And these things can range from solubility to potency to right down to the types of dosage forms that are needed. A lot of times trying to build a facility around a selected dosage form is not going to work out the best, especially if you start to look at different types of products that you'll be moving into the future, different technologies to increase the bioavailability, to increase processability, things to increase shelf life, or more importantly to increase shelf presence, fixed combinations, and things like that. The modular design and facility approach usually presents the most pragmatic application of that. Again, keeping the processes modular so that we can use these and mix and match as we see fit, building around an aspect of what an optimal batch size will be. One of the things that happens continually that I've seen, at least in our consulting business, is that the market demand has a tendency to grow unexpectedly. And what I've seen, especially now in a lot of the areas, especially in the oncology areas, a lot of companies have to go to market with the clinical service form. And that poses a unique problem because the clinical service form has not been designed to optimally be manufactured, and market demand quickly outstrips your ability to manufacture. In a lot of cases, had the pilot facility and the smaller capacity been aligned and set up in such a way that it was modular, meeting the market demand by making multiple batches or aligning different processes so that we can synergize them, we probably would get around that problem. So this has a lot to do with Mike and Sam's excellent background in designing these type of facilities and some of the fundamental problems I've run into in our pharmaceutical consulting business. And a lot of the things too gets into capital limitations, and one of the things is how much you're going to spend up front, net present value, as opposed to what are you actually going to be doing against the operational costs. And Mike is going to touch on some of this where it turns out you have to balance these. A lot of this becomes a business strategy. You know, how much is a batch going to cost me versus how much is it going to cost me in multiple batches? You know, again, balancing testing. So, without further ado, we're going to get into some process development aspects, and I'm going to turn it over to my buddy Mike. Go ahead, Mike.
When developing your batch size, it's very important for you to contemplate or balance your capital costs versus your production ability. Large batches give you the ability or the advantage of making a large quantity of tablets or capsules, but they require a much larger piece of equipment or multiple large pieces of equipment. Large batch sizes with multiple unit operations will then require you to have transitions of large quantities of powders and IBCs from one part of the facility to another. And these large IBC movements will probably require automated pushers or bin lifts due to the ergonomic challenges of maneuvering this large equipment. Larger IBCs and larger equipment also have larger utility requirements, and when cleaning will require you to have a lot of USP purified water or DI water for your final rinse. The advantage of going with smaller batches is you get to purchase more cost-effective equipment. However, you'll have to produce more batches, which will result in additional sampling and testing. The objective really is to try to find the perfect balance of batch size that will allow you to reach your annual production rate and maximize the efficiency of your equipment in a 75 to 80% efficiency range, meaning that your equipment is only down 15% of the time. And if the market demand shifts, you can always reutilize that extra 15% or add additional shifts or additional days of manufacturing. One emerging or re-emerging philosophy in pharmaceutical manufacturing is continue processing. Numerous equipment vendors now are developing and offering equipment that will allow you to execute continuous manufacturing of oral solid dosage products. It usually is one or multiple unit operation steps in their offering. Depending on the complexity of your product, it definitely makes sense to research the current options and see if your product can utilize continuous operations. But be careful when evaluating continuous manufacturing. It's very important to identify how you will segregate batches for quality sampling. Typically, we'll use a time duration or a changeover of bulk ingredients that designate a batch or lot changeover. It is very important to consider how you're also going to dispense the ingredients and stage the ingredients for continuous operations, as you'll continuously need to change and recharge these ingredients into the manufacturing operation. Another philosophy that has a lot of traction in the pharmaceutical industry is single-use technology. Single-use technology or disposable technology eliminates the need for cleaning. This elimination of cleaning can reduce utility costs and in most cases lower production changeover times or your downtime between unit operations. Single-use isolators can be utilized for dispensing, sampling, and equipment charging. Single-use mixing vessels can be utilized to create formulation or coating solutions or granulating solutions. Single-use IBCs or bin blenders can execute material handling operations and can be transferred around the facility and are much lighter than their stainless steel equivalent. However, with single-use equipment, there is an inherent risk of tearing of the bag. So it's very important to do your due diligence in testing and retesting the equipment to make sure it'll work in your application. There is also an increased operating cost associated with the purchasing of single-use shells or replacements, so you need to identify that in your evaluation process. The last thing I'm going to talk about today is scale out versus scale up and the advantages. The advantage of a well-designated pilot scale or preliminary batch is that as market demand increases, a facility can simply scale out, meaning they can mimic the existing manufacturing suite in an adjacent or local manufacturing area. Instead of developing a new manufacturing operation with equipment twice the size that can produce double the quantity of material, you're simply doubling your manufacturing operation or your operating train. There are numerous advantages to this concept. First, you already have design documentation for the fabrication of your manufacturing facility and the purchasing of your equipment. These designs and equipment specs can be repurposed and given minor tweaks so that you can construct and buy out your facility in a quicker timetable. Secondly, since you're going to utilize identical equipment, you can reutilize your commissioning and validation protocols to bring your facility online quicker. And also, any lessons learned during the execution of the protocols can be avoided on the second pass. And lastly, since you already are operating the same equipment, your startup procedures can be limited to running some stability batches and doing some final tuning of the equipment.
Thanks, Mike. This is Sam Halaby. I wanted to talk a little bit about facility design. Capital expenditure is an important aspect for any business. For multi-product facilities, the need to incrementally grow, contract, or reconfigure is commonplace. Therefore, when developing a design approach for these types of facilities, consideration should be given to both flexibility and investment. One of the keys to a successful multi-product facility is the ability to quickly adapt to newer requirements while minimizing the impact on existing operations. So when we're establishing the design approach of multi-product facilities, flexibility is paramount. Flexibility is ultimately a function of the ability to support a wide variety of products and processes and therefore an understanding of these two contributors is essential. As Russ and Mike presented, there are several opportunities to integrate flexibility into our processes, whether it's scaling out, continuous manufacturing, or utilizing single-use technologies. From a facility standpoint, modular design concepts can offer a solution that provides flexibility and manages capital expenditure. If we look at the overall manufacturing operation and the interrelationships between processes, we can begin to establish modular cells that can act as building blocks to be added, removed, or shifted as needed to meet ever-changing business needs. With this approach, a myriad of configurations are possible. To help focus on modular strategies, a framework can be established which addresses process technologies, operational adjacencies, lean manufacturing principles, single or multi-story configurations, operational flows, and the accessibility to mechanical and technical areas. With an understanding of these basic elements, a clear foundation can be laid for a flexible modular facility design.
Well, there you have it. Sam and Mike always continue to surprise me with their pragmatic knowledge and experience in this area. And again, I think it pays to rethink a few things here as we wrap this up. Remember, in most cases, if you produce a pilot or said clinical batch that's of a mid-size, the ability to use a modular approach where you would scale out, which means you make that mid-sized batch in multiple units. In other words, you just clone out the batch. We heard the advantages and the leverage that you can realize there. The ability with a clinical service form, which is made at a smaller batch size. Again, the ability to manufacture that in a modular form works very well without a significant capital investment. And again, the approach with scale out to scale up also lends itself to hybridization or a hybrid approach to continuous processing. So what do we have? Again, the continued success of multi-product facility depends on operational areas designed with multifunctionality, which can allow the owner to adapt to market demand, product changes. Appropriate design decisions for a facility will afford the operators the flexibility to change out unit operations for various drug products, as well as the capability to scale out in order to accommodate the dynamics of capacity and market demand. You don't necessarily have to build a giant facility with 1,000-liter capacity to be efficient. Thank you.